the definite integral from 1 to 9. So the lower limit a is 1, the upper limit b is 9. Okay, this one is called lower limit, and this one is called upper limit. And the function we have three pieces. We have 3, we have 1 over square root x, and we have e to the power x. So we're gonna start with using the rule that the integral of the sum is the sum of the integration. We can treat it as the integral from 1 to the 9 of the 3 with respect to x plus the integral 1 to 9 of 1 over square root x with respect to x minus the integral from 1 to 9 of e to the x with respect to x, and treat it one by one. Okay, the first one is called the constant integration. That's from the integral of the k with respect to x is kx. Okay, the second one, we have 1 over square root x, which is 1 over x to the power 1/2. Write it as a power. When you see the power, this is x to the power r, and r is not -1. So we're gonna use the power rule. What the power rule? The integral x to the r with respect to x equals x to the r plus 1 divided by r plus 1. Okay. And the last one, this is the exponential term. We're gonna use exponential rule. What is exponential rule? The integral e to the kx with respect to x equals e to the kx divided by k. For this case, e to the x means e to the 1 times x. Therefore, k is 1 for this case. Okay. I identify each one and identify the rule that we can apply for each term. The next step, we are going to find the antiderivative of each term. Just find out. For the first term, the constant is 3. So the antiderivative is going to be 3 times x. Okay. We are done we already applied the antiderivative rule. The integral sign will be gone. So we're going to put the bar instead. So 1 to 9 of this expression. And then the second one, similar way, going to be x to the power. The r is -1/2. So going to be -1/2 plus 1. And the simplified term going to be +1/2, right? So you're going to divide by that number, the same value from adding the original power with the value 1. And then evaluate from 1 to 9. So this is one expression. And the last one, so it's negative side, sorry. It's minus, not the negative side. This is minus, oops, where did it go? The next is minus side. And e to the power kx over k can be e to the 1x divided by 1. So 1 you can ignore because anything divided by 1 is the same as that original term. Now we have 3 terms, but all of them have the common bar here. I'm going to consolidate, write it in one package. So in same expression, 3x plus divided by 1/2 means multiply by 2 over 1. X to the power 1/2 means square root x. Okay, and then minus e to the x. So if you need more detail, so this is x to the power 1/2 divided by 1/2, or square root x multiplied by 2 over 1. Therefore, we get 2 square root x there. And we're gonna evaluate from x equals 1 to x equals 9. Recall when you evaluate, you're gonna replace the upper limit first. So you're going to have 2 groups of the numbers. So 3 multiplied by 9 plus 2 times square root 9 minus e to the power 9. This is from the substitution x with the upper limit, subtracted by another evaluation when you substitute x with the lower limit 1. Okay. and then simplify as much as you can or use the calculator, up to you. So far, I know that I can clean up using without using the calculator, as this is 27 plus 3 times 2, that's 6, minus e to the power 9, minus 3 plus 2 minus e. And I have the first one as 27 plus 6, that's and also minus 5, so I consolidate number here, 3 and 2, that's 5, reduce with the 6, 3 plus 1, so the real number gonna be 28, minus e to the 9, negative becomes positive. So this is the exact value of the solution, okay? But if you are going to use the approximate, because most of the problem, they're gonna ask you to write in the round to 2 decimal places, something like that. So I'm gonna use my calculator to simplify the number, or to write the number in the decimal form. You can use the calculator to check out the value as well. So I will get the value as negative 8072.37. So let's check one more time. Yep, we got the same number. So either in the exact form, that means in the e to the power form, or in the decimal form, so either one. So that's the answer for this definite integral problem.